In this first video, we're going to talk about area of quadrilaterals. First, we need to know what a quadrilateral is. A quadrilateral is considered a four-sided closed figure, and it has no curved lines. Now we're going to take a look at some examples and non-examples of quadrilaterals. Well, our first example of a quadrilateral is that, as shown, it's a four-sided figure, it's closed, and it has no curved lines. In our first non-example of a quadrilateral, we have four sides. However, it is not a closed figure, so that's not a quadrilateral. In our second non-example of a quadrilateral, we have three full sides and that curved line, which makes that not a quadrilateral. Next, our triangle here, it's the three-sided figure, it's closed, it has no curved lines, but it's only three sides. We can think of area as the space inside a figure, or how many unit squares can fit inside the figure. Before we talk about area, we need to find what base and height means. Base is the side that your shape sits on, and the height is just a line segment that meets the base at a 90-degree angle. As a side note, a 90-degree angle is shown as a small box inside or outside of a shape. If we use the sample picture inserted just a second ago, notice that we have four 90-degree angles there. We have the bottom left corner, bottom right corner, top left corner, and top right corner. Remember, those are small boxes, so that represents a 90-degree angle.
Yes. Now I want to think of it as loop-de-loop-de-loops.
A first type of quadrilateral we'll look at is called a square. As many of you know, a square has all sides of equal length and four 90-degree angles. Notice that each side of the square is 3 inches in length. Our base of the square is going to be 3 inches because that's the side our square is sitting on, and our height of the square is going to be 3 inches as well. That's the segment that meets the base at a 90-degree angle. The area of our square is going to be represented by base times height. Again, we said our base is 3 inches and our height is also 3 inches. And 3 times 3 gives us 9, and inches times inches gives us inches squared. So the area of the square is going to be 9 inches squared. Our rectangle is going to be the next type of quadrilateral we'll look at. A rectangle is signified by one side generally being larger than another side. And it also has four 90-degree angles. Similar to the square, the area of a rectangle is going to also be represented by base times height. Well, our base is 5 centimeters and our height is 2 centimeters. And 5 centimeters times 2 centimeters gives us 10 centimeters squared. Again, 5 times 2 is 10. Centimeters times centimeters gives us centimeters squared. The final type of quadrilateral we'll look at in this video is called a parallelogram. A parallelogram has two pairs of parallel sides, opposite sides are parallel, and two pairs of equal sides in length. Notice what happens if we insert one of the parts of that parallelogram. Notice that this part here is just the same as that part right there. Here's what we're going to do. We're going to take this part of the triangle from this part of the parallelogram and we're going to put it over here. Here's what we get. Doesn't that just look like another rectangle? Well, we already know how to calculate the area of a rectangle. The area of a rectangle is just base times height. Our base in this case is 2 inches and our height is 1.125 inches. And 2 inches times 1.125 inches is 2.25 inches squared. And that's the area of the parallelogram. Again, the area of the parallelogram is base times height. So when you're given a parallelogram, always watch out for that dashed line.